Welcome to the Trucking Risk and Insurance Podcast. We're your hosts, John Farquhar of Summit Risk Solutions, and myself, Christopher Charles Harris. I get the opportunity to talk to a great many people that know a few things, a lot more than what John and I know. And this week is no different. Mr. Jim Park, an independent journalist, joins us this week, and he was recently at the Advanced Clean Truck Expo in Anaheim, California. And Jim's going to talk to us about what is coming down the highway at us in the way of technology.
Welcome to the Trucking Risk and Insurance Podcast.
Mr. Park, Jim, how are you today?
How are you doing,
Top
Jim?
of the world, Chris. Doing great. How are you?
I couldn't be better. I've been busy. I've been working. The weather has turned around, it looks like I might actually smoke a cigar today.
Don't do that. You'll wreck the environment.
Oh,
Have the activists chasing you with a fire hose. Don't do it. I'm warning you.
You're probably right, but we're not here talking about activists today. We're here talking about trucking technology and what the heck is coming down the pipe, because you and your experience, you get exposed to a lot of technology. What is coming down the pipe, Jim?
Man, you name it, it's coming our way. I was down at the Advanced Clean Truck Expo in Anaheim, California last week.
Oh,
So 4 days on the ground. Everything imaginable under the sun to do with decarbonizing trucking was there. Battery trucks, hydrogen trucks, natural gas trucks, chargers, you name it. Technology is mind-boggling on the decarbonizing side. On the safety side, we've got all these advanced driver assistance systems, they call them, ADAS, emergency braking, cameras. Really amazing what's going on the safety front as well. And yet we still have, fairly low level of enthusiasm amongst drivers for some of that technology. Some of it's understandable, the surveillance culture, et cetera, et cetera. They're working on ways to mitigate some of those driver concerns, I think. But we can talk a bit about that as we go along here. It's just really, ever since big tech, Silicon Valley decided trucking was a market that needed some disruption, we've been disrupted, and it's going to continue happening for a while. I'm not bought into all of it yet. I think some of it's kind of superfluous and maybe kind of whiz bang and nice to have if you want to impress your girlfriend. But I'm not too sure how much of it's going to have a really long and lasting impact on truck safety, but we'll see. I've been wrong before.
well, before we I think truck safety, I didn't know you were at the show. So we'll get into truck safety, but before we get into that, let's talk about the environment and everything. What is decarbonization? What's your definition of that?
Stay home because the batteries won't take you far enough. No, I mean, it's the buzzword now. Everybody's trying to do whatever they can to eliminate trucking or reduce trucking's carbon footprint. So decarbonization, that's the buzzword. It's working in very small degrees at the moment. We've got some penetration of battery electric light trucks, delivery
Right.
trucks, package vans and what have you. They're making their way onto market now. You can actually go out and buy one, like put your money down and drive it home. You may not get it out of the parking lot again because there's no charging infrastructure, but that's another story. We're working on that too. And on the heavy side, well, not so much. We've got all the major OEs now and a few others are producing Class 8 battery electric tractors. Limited range so far in the 150 to 200 mile range, which in some applications is fine. Nobody's arguing with that. But trying to push over to the long haul side is going to be a real challenge because we don't have the range in the batteries, of course. And we don't really have a suitable replacement for diesel yet.
Because the reason, Jim, range is such a big thing in electric vehicles. I mean, I drive an electric, so I'm conscious of range all the time and charging infrastructure. So you hit a couple of points there that range isn't there yet, nor is the infrastructure. What does the future look like for both of those if you want to tackle them one at a time, maybe?
Well, let's start with the infrastructure first. It's the critical element right now. It's a mess, frankly. Nobody's really sure, and it depends who you talk to. I don't really have a position on this because I'm not smart enough to be able to figure it out. The advocates insist that we've got the capacity in the grid to do this. I'm not sure that's the case. And I've heard a lot of people saying the grid's already stretched to capacity and, at certain times of the day in certain locations. And typically when we say that, we're talking about California. So let's just be clear. If you're in Kansas or New Hampshire, probably not as big a deal as it is in California. But frankly, the push to decarbonize, electrify trucking hasn't pushed its way far enough east yet for those jurisdictions to be sort of taking notice of the problem. But we talk about Texas, we talk about California, both having stressed grids. We saw what happened in Texas a couple of years ago with that ice storm, shut everything down. Now it's many years away, but just imagine that your entire transportation infrastructure is electric now. So you have no trucks going to grocery stores, you have no trucks, no ambulances, no buses, no anything with more than four wheels running around doing what they normally do. Utility companies going out after a thunderstorm or a hailstorm to fix the power lines and the utility lines that have all fallen down. Well, if they're not diesel, then they're pooched. Or fix the problem and they're grounded by that same problem. So, I mean, I really am talking a long time in the future before the concentration of electric vehicles gets to that stage. But it is.
Well, I was going to say, you've even got, harsh weather events, in the southeast, hurricane season when it comes up, rolling across Florida in the south. And then the Northeast, we've seen this unfortunately before, Northeast and even Southwestern Ontario in particular, is when they get those really hot, humid time periods and everybody, the utilities are screeching at us, don't be turning on your air conditioners. You're overpowering the grid. Well, what's going to happen when we got transportation sucking a lot of that out of the infrastructure right away? And now all of a sudden we have a blackout like we did back in, when was that? 2003, 2004, which caused a big shutdown.
Yeah.
Yeah. And just to be clear though, Jim, just for anybody listening, as I said, I drive an electric car. I don't think electric cars are going to have the same impact because I charge at night when most of the power is readily available. That wouldn't be the same though for transportation. They need to charge when they're empty. They don't have the luxury of kind of scheduling their charge.
That's part of the equation really, is when you charge. It's not so much how much you use, which obviously is a concern. But if, like you said, everybody's drawing it off, 9 to 5, Monday to Friday, then we're in big trouble. But if you look at the delivery infrastructure, all the package vans and what have you, they tend to run Monday to Friday, 9 to 5. So they have to charge overnight when typically the grid is less stressed. And you also have untapped renewables. I'm speaking mostly about hydroelectric here. All night long, water keeps going over the dam and there's really nothing to do with that energy. So they turn off the turbines and let it go. If that could be harnessed, they say, that would add a lot of additional electric capacity to the grid. And the nice thing with batteries is you don't have to use it as you produce it. Like you turn on your kettle or your toaster. Your car, as you know, sits in your driveway overnight, charges at 2 a.m. when everybody else is asleep. Get up in the morning and away you go. Well, it's more or less the same for trucking and transportation. There's also really nobody knows for sure how this is going to work out, but very few people are expecting these trucks to go right down to zero. They'll be coming back to the yard with 20% charge still on them, 80%, 60%, depending on the routes they put the trucks on. So every day is not going to be a matter of 100% capacity drawn off the grid for every truck that's out. It could be as low as half of what, the battery capacity actually is. Sun doesn't shine obviously during the night, but the wind continues to blow. So you've got some renewable energy there from windmills. And you've got, untapped resources in hydroelectric and even nuclear when they throttle those plants down. The natural gas plants all tend to throttle down at night. So if all that could be ramped up, actually they say it's good for the grid if it runs at higher capacity all the time. It's more efficient than turning it up and down. So if you figure you add, a few thousand trucks to a power distribution outlet, it's going to demand a lot of output from the utility, and they'd probably be happy knowing that all that draw is there because they can run their systems at a higher level, but at a more efficient level. So technically, that's a good thing.
I really believe that the first part of trucking to go electric will be the last mile delivery segment. The Amazon or the internet shopper delivery package thing, which is growing like crazy at the moment, as we all know. I think that'll be the first part to get it electric because, as you say, they're delivering during the day and then they're going to be charging at night. And the range isn't huge.
We're seeing some of that now.
It's actually quite small.
Yeah.
Yep. Well, I was going to say a good study that we're seeing right now, PepsiCo, and with the Frito-Lay and Pepsi, they've already taken delivery of some Tesla vehicles out in the California region, and they've got a limited range, but they're working with that range for the purposes of what they're doing, and it seems to be so far successful.
Yeah.
What the fleets and the OEMs have been able to do, thanks to telematics, basically, is track those vehicles to within inches, and milliwatts on a trip. When they say, what's the range of this truck? 150 miles. The variables there are enormous, weight, weather conditions, ambient temperature, and even the way the driver operates the truck. Opportunities for regenerative braking, for example, top up the charge in the battery. So to say 150 miles is not really a good way of looking at this. And every truck is going to be different. So once the fleets understand the use profile on that truck, they can say, okay, I've got a 78-mile route, and I'll run that, Monday through Thursday. And then on Friday, I want to go 150 miles. Well, obviously, that truck's going to probably not make the 150-mile trip. But why would you put that truck on a 150-mile trip if you were pretty sure it wasn't going to make it? Send the diesel out.
Yeah.
Or relay it somehow. Work out a charging arrangement with your customer at the other end. But for the applications where the fleets understand the operating profile and the opportunities for charging that exist on the way, and over time with trials and, examining the profiles of various routes that the drivers have actually run, they know exactly, to the watt, how many kilowatts it's going to take to get the truck from the yard out to the delivery point, make 2 or 3 stops and back to the yard at night, and still have 40% charge left on board. So range in that respect is not a concern at all. They understand that. It's when they try and push the envelope and go further than the trucks are really intended to go. But getting back to what we talked about earlier, where are we going to put these trucks? Well, the obvious case is put them where they work. Put them where the ranges are compatible, the duty cycles are compatible, and drivers have some opportunity for charging en route. Various customers now, I was talking to the folks at Schneider down at ACT in California, and they're actively working with some of their larger customers to install charging facilities on the customer site. So the Schneider truck drives in, backs into the door, driver hooks up the cable. They're 45 minutes, 2 hours, whatever, loading, unloading. The truck is charging all that time. So presumably it'll pick a number, 50%, 60% of its charge in a couple of hours. It's the last 20% that's the hardest to charge. So if we keep things below 80, the charging is actually relatively quick. So there you've got a good case where now the truck can go, let's say 200 miles to a customer, charge for 2 hours while it's loading and unloading, and come back, charge up again, go back. It becomes a lot more practical. But to simply say, I'm going to get up in the morning, my truck will be fully charged at 100%, and I'm going to drive for 250 miles and then it puke. Nobody's going to accept that.
Yeah.
Well, as I say, I drive an electric, and it causes you to change your plans, especially on those longer trips. You have to plan differently. I enjoy it, but I also accept it. For some drivers, it's not ready for long haul yet. But let me ask this. We've been talking about electric. It's not ready for the long haul. It's not ready for Chicago to California yet. But are there other technologies out there such as hydrogen is one that comes to my mind, that might be ready, or is the future of the newer trucks going to be electric? What do you think?
Well, there's room in the market for everybody. At this stage of the game, we still don't, have dilithium crystals or flux capacitors. So we have to rely on more traditional technologies. Hydrogen, I did an interview with a guy, a Cambridge University professor who's got a long and storied career in trucking, examining trucking issues. He's not unfamiliar with what we're up against here. And he laid out for me some pretty damning statistics on hydrogen, why it won't work. It was a really good interview, I thought. It opened my eyes. I don't want to rain on hydrogen's parade here, but people say, and have been saying for years, hydrogen is the fuel of the future, and it always will be. Because of the practical applications for it, yeah, they exist, but the problem with hydrogen, it's the most abundant element in the universe, period. But it never, under any circumstances, exists in its pure form naturally. You have to extract it from something. So water, some hydrocarbon like methane or natural gas. And in the conversion process, so much of the energy, the original energy, is lost to create the hydrogen. It almost makes it, well, as this Professor David Sibon is his name, from Cambridge, he laid it out that if you start with 100 kilowatts of energy and you electrolyze water, when that process is finished, you've only got 70% of the energy content or less left from what you started with. So from 100, now you're down to 70. You've got this unit of hydrogen that's whatever you manage to produce for 100 kilowatts, but there's only actually 70 kilowatts worth of energy in this little bit of hydrogen. So then you take that hydrogen and you transport it and compress it first, then transport it. There's more losses in there. And then when you get to the fuel cell, where you're converting the hydrogen back to electricity, sort of the reverse of electrolysis, it's only 50% efficient, that process. So now you've taken 100% to 70%. You've got, say, another 5 to 10% for the compression and transmission. Now you're down to the fuel cell. So you've got 50% of 60% of what you started with. Now you're down to 30% of the energy that you started with. Put the wheels, you lose another 4 or 5% in the motors and the transmissions and everything. So, okay, there's inefficiencies there, big inefficiencies. But somebody has to pay for that. Because to produce this volume of hydrogen, you have to pay for 100 kilowatts worth of energy from the grid, right? Or you have to build out enough capacity that you can produce 3 to 4 times as much energy to produce an equivalent volume of hydrogen than if you had batteries or diesel or natural gas. So all that to say, it's in a lot of ways horribly inefficient in terms of the energy that's lost in the process. That doesn't actually make it to the wheels.
So
then there's the issue. Maybe I am burying hydrogen here. The other issue is, how do you produce this? Electrolysis is the obvious answer. It's green, right? That's what everybody wants. So you have water flowing over dams all night long. You plug in an electrolyzer and poof, you get hydrogen. That's great. But we have no electrolysis capacity to speak of in North America at the moment. It's being built out, but years, 5 to 10 years before it becomes commercially viable. The way hydrogen's produced, and this is amazing, the way hydrogen's produced now for industrial purposes is called steam methane reformation. Complicated process, but they make it with natural gas and methane. And they superheat water to 1,000 degrees to get this steam. They get this 1,000-degree steam and they mix it in with methane gas. Somehow, chemical engineer guys could tell you all about this, but it splits the methane into carbon dioxide and hydrogen, CH4. That's a hydrocarbon molecule. So you get all this other stuff that you don't want, right? The methane from the hydrocarbons, that you're using, according to Saban, you get 1 kilogram of hydrogen, or to get 1 kilogram of hydrogen, you also get 9 kilograms of CO2.
Oh,
which is the stuff we're trying to get rid of, right?
yeah, exactly.
Now,
How?
this is the amazing part. This is the amazing part. Saban says a kilogram of hydrogen contains the same amount of energy as a gallon of gasoline.
Hmm.
When you burn a gallon of gasoline, you get 9.8 kilograms of CO2.
Mhm.
It's taken you 9 kilograms, or you've produced 9 kilograms of CO2 to produce that 1 kilogram of hydrogen.
Mhm.
Unless I'm doing the math wrong,
Mhm.
it's the same.
Mhm.
We burn hydrogen at a much lower efficiency.
Yeah.
We produce all this CO2. It's the same as a gallon of gas, or basically a gallon of diesel. How is that achieving decarbonizing trucking?
Yeah. Definitely not official.
And if you don't believe me, go online, Google David Saban, hydrogen, and you'll read all kinds of stuff that he's written, all kinds of papers he's done on this. No reason to doubt he's wrong. And the hydrogen people are pretty quick to downplay what he's saying. I mean, the train's left the station. There's too many people on board now with hydrogen to let any of those details slow anybody down. But hydrogen's going to remain even the price of a hydrogen truck, for heaven's sakes, $500,000-$600,000 compared to a battery electric truck at maybe $300,000 to $400,000.
Okay.
Mhm.
So,
And with a
Right.
hydrogen truck, it's essentially an electric truck, right? You've got a battery, you've got motors, you've got wheels, but you've also got the fuel cell, which you don't have on a battery electric truck.
Mhm. Mhm.
well, that's one of the things I wanted
So
to say
that
about
adds a
electric.
lot to the cost, plus the tanks and everything else.
Yeah.
It doesn't come for free. And I should say here, I'm shoveling madly on hydrogen, but the battery side of this is equally nasty when you get into the CO2 emissions and the mining problems and the, tearing up sensitive environmental areas, human labor to extract the mine from these poor countries that, will do anything for $1 practically because they're in such economic straits. Lithium mining company knocks on their door and do whatever you want. And we'll throw how many of these poor people at the mining project and get everything going. It's an environmental catastrophe waiting to happen unless it's done right. Indonesia and places in Africa, they don't do things right because nobody really holds their feet to the fire.
Mhm.
In Canada, we're talking about doing a lot of mining up north. I'm going to give them the benefit of the doubt here and say they'll probably do it right, but it'll be too expensive on the world market.
Mhm.
Nobody will buy the stuff. They can still buy it from China and Indonesia and other places that produce it for much, much less. So either way you look at it, we've got humans have a big, messy, dirty footprint. And, we leave it behind wherever we go. So whether it's diesel or gasoline or natural gas or hydrogen or batteries, there's no free ride here, folks. There is no
Mhm.
clean transportation. You
Mhm.
pay for it one way or the other. And it's an utter fallacy to believe otherwise. And these people that talk about zero emissions trucking make me crazy. Zero emissions at the truck, yes.
Mhm.
There isn't a tailpipe.
Right.
But the upstream emissions on some of this stuff, man, it is mind-boggling.
Yeah,
Sorry,
I mean,
that's my
we can get into, well, no, but things like recycling the batteries is one big conversation about how energy efficient that can be done. And I'm sure we're going to make improvements. But just going back to hydrogen, so what I heard you say is you don't believe that hydrogen is the future of trucking. Is there something else that's might be the future of trucking other than electricity and diesel? Because diesel's going to be around for a while yet.
Well, the answer to that question is blindingly obvious. Natural gas,
Mhm.
Okay.
especially renewable natural gas made from, biodigesters and manure ponds and landfill sites. If you go back to what I was saying about hydrogen, they make hydrogen from natural gas.
Methane,
So
yeah,
why
you
take
said that.
natural gas and go through all this stupid process? Why not just run trucks on natural gas?
Yeah, yeah.
And
I mean,
you're
we're slow here in Canada on the uptake. I've spoken with people from Enbridge, and there's something like 0.08% of the trucks in Ontario are running on natural gas right now. Very, very tiny number. In California, where they have incentives and programs in place, 98% of the trucks that are burning natural gas in that state are running on renewable natural gas. In fact, they tell me they're running out of tailpipes to put the stuff in. And they're producing so much of it now because of all the tax credits to, tap this stuff from landfills and what have you.
Yeah.
And just so you know, renewable natural gas is kind of a misnomer, especially the N word. People go, natural gas. It's a methane product that's derived from biodegradable organic material, like waste, not couches, but food, manure ponds, biodigesters, plant waste, algae, you name it. All this stuff, when it decays, produces enormous amounts of methane. So the beauty of this is you get...
Now that we've overcome Jim's technical difficulty, you were just saying about natural gas and the fact that it's a methane product.
Yeah. At the end of the day, natural gas, that we run in our stove, the stuff that actually burns is methane. And ironically, the same stuff that's produced by biodigesters and landfill sites and, all sorts of other sources. So when you call something natural gas, everybody goes, oh my God, fossil fuels, the oil patch, shale, fracking, blah, blah, blah. They get all excited. That is a problem. There's no doubt about that. I've got some figures on fugitive emissions as well that are kind of scary. But when you take a methane product from a manure pond, capture it, clean it up, and then burn it in a truck, you're accomplishing two things, two ways of reducing carbon. First, you're removing that stream of methane from ever entering the atmosphere because you've captured it. Then you burn it in a truck, you make it go away, and the carbon intensity figures from burning renewable natural gas in a truck, which is already cleaner than diesel from a CO2 point of view, is you get a double benefit. And depending on the source, even the California Air Resources Board and the EPA have charts and figures that cite some forms of methane used in a renewable natural gas environment can be as much as 300% lower than the CO2 produced by a diesel.
And people are
100%.
And people are pretty good at creating waste that in turns will create.
We're very good at creating waste. Yeah.
Yeah.
Well, whether it's
there's a truck
or...
fleet in Indiana that burns renewable natural gas from their manure ponds. It's a dairy farm. They have 500 cows, 50 trucks, and the output from that manure pond powers those 50 trucks every day. Plus it runs the entire facility, the entire dairy, and they sell stuff back to the grid.
Wow.
500 cows do all that.
Jeez.
Why aren't we moving more to natural gas?
I didn't catch what you said there.
Yeah.
Yeah. What?
It's the N word. The environmental activists won't get past the fact that it's natural gas. It isn't. I mean, we should be calling it something else. RNG is the sort of standard term for it, renewable natural gas, but that's still got the N word in it. And I don't think they can get their heads around. Ontario, I've spoken to the Enbridge people, and they've got a couple of trials going on at a few landfill sites. In fact, there's one here in St. Catharines at the Walker Brothers quarry. They're just playing with it. They're dipping their toes in the pond, whereas in California, you've had, the waste hauling fleets literally driving into the landfill site to dump their garbage. They drive around the other side of the landfill site, hook up a hose, and take the methane off the garbage they just literally dumped and drive out the gate. It's a circular economy that they provide their own fuel by bringing in the waste products to the landfill. It's been running down there for 10 years like that.
Wow.
And
wow, that's
we're
quite
figuring that out here now, way behind the times. And, you know, we've got this initiative in Canada now, the hydrogen economy. We're going to move this forward and, you know, become a world leader in hydrogen production. Well, hell, okay, do what you want to do. You know, I'm not going to argue with the politicians and the environmentalists, but dumb little Jim Park thinks there's probably a better way. And I know landfills are a great source of this product. We've got lots of dairy cattle around the province of Ontario, dairy farms all over, especially Eastern Ontario.
Sure.
I don't know what they do with their methane or their manure ponds. Certainly there's a huge resource here that's going untapped. And, you know, natural gas really got a bad rap with that Cummins 12-liter engine. I mean, it doesn't work very well. It's underpowered for what we do here in Ontario. Everybody was on board with that 15-liter high-pressure direct injection engine from Cummins Westport. They pulled it off the market. Everybody was, oh, no, what are we going to do? Well, Cummins is coming out with a new 15-liter natural gas engine, which I had a ride in down in California. Didn't get to drive it yet, but Cummins is really excited about that. Really could be a game changer if truck fleets can get a 15-liter engine powered by natural gas that'll run on renewable natural gas. That might be the tick that might pretty much finish off hydrogen as far as a fuel for the future is concerned. It's there now. We're swimming in this stuff. Let's put it to good use.
I know we ended that a little abruptly, didn't we? My apologies for that, but Jim has so much information that we decided to make this interview into 2 episodes. So join us next week for the conclusion where Jim starts to talk about safety. What did he see at this recent truck show in regards to safety and advancements for the trucks and for the drivers? So join us next week on the Trucking, Risk, and Insurance podcast. And don't forget to click like and subscribe. We'd appreciate it so much. Leave comments down below. John or I will answer them. Thanks so much. That's it for this week.